Welcome everybody. My name is Boglárka Pethő, and I'd like to present the progress of my PhD project investigating the role of maternal age on the occurrence of the non-chromosomal congenital abnormalities. I'm working as a specialist at the obstetrics and gynecology department of the Semmelweis University. My vision is a Hungary where pregnant women receive the state-of-the-art pregnant care, which is the key to guarantee the best chance for the new generations. And on this way, my mission is improving the screening methods of non-chromosomal congenital abnormalities. On this way, I've got two ongoing projects to reach my scientific goals. We investigate the same question on a nationality level by a population-based study and on a global level by a meta-analysis. Please let me start with the population-based study. Congenital abnormalities are really frequent, about a 3 to 5% worldwide prevalence. And in Hungary, this frequency is the same. The reason, because it's really relevant to investigate this question in the Hungarian population, that about 30% of live births fall into the high-risk age zones in the Hungarian pregnant population. So our clinical question was, which maternal age categories show the highest risk of different birth defects in the Hungarian pregnant population? I'd like to shortly present our study design. We collected our data from the Hungarian Case Control Surveillance of Congenital Abnormalities, which is a really unique database as its size, its comprehensiveness, and wide range of data. So we've got really detailed information about more than 30,000 pregnancies. And we compared our data with data from the Hungarian Central Statistical Office, so we analyzed more than 3 million pregnancies during the study period. I'd like to present shortly our results. At first, we analyzed together non-chromosomal abnormalities. It was our first outcome, and I'd like to shortly present our statistical approach, because it's a novel statistical approach. In general, in literature, researchers use arbitrary age categories. And our concept was, at first, identify the best 10-year age category for the maternal ages. And we used this best 10 years as a period which we compared each maternal age years. And we identified the relative risks for every maternal age years. And as visible on this graph, we can see that both very young and advanced maternal ages increase the risk of non-chromosomal congenital abnormalities. On the next slide, I grouped the non-chromosomal congenital abnormality categories by influenced them from the maternal ages. And in the first slide, you can see the categories which are influenced by advanced and both very young maternal ages. I would highlight the circulatory system because of its severity and its frequency. And in this case, we've got an additional examination method, the fetal echocardiography, to improve the detection rate of them. You can see here the urinary system and facial abnormalities, which are influenced by advanced maternal age. And there is only one group, the nervous system, which is influenced by a very young maternal age category. And we couldn't find a correlation between maternal age and respiratory system, but it can be because of the low case number. And we hope with this new knowledge we can specify screening methods and implicate them for the recommendations of the fetal echocardiography and fetal neurosonography. And for future, we would recommend to investigate the biological background and justify the role of maternal age with a multivariate model to better understand this correlation. The main strengths of our study are the huge case number, the unique database and data collection methods, and the novel statistical approach. While the limitations are the long study period with the changing detection rate, and the data collection ended in 2009. We submitted this manuscript and we are waiting for the answer. And please let me continue with our second project. This is a meta-analysis in the same topic. As I mentioned, non-chromosomal congenital abnormalities are really frequent, and they are the leading causes of infant mortality and morbidity. Why is it important to investigate this question by a meta-analysis? The literature is really inconsistent. As you see this graph, you can see that chromosomal abnormalities shows a really sharp increase with maternal age. But we've got less exact information about non-chromosomal abnormalities. And because of this is a gap in the literature and also in the recommendations. So our aim is to identify risk groups regarding maternal age. Our clinical question is quite the same: which maternal age categories pose the highest risks for different birth defects? We carried out a systematic search in October in the 3 comprehensive databases, and in the end of selection period, we've got more than 100 articles for the mathematical synthesis. On this first result slide, you can see non-chromosomal congenital abnormalities together. We could analyze 9 articles with homogeneous age categories, and we found that both advanced and very young maternal age increases the risk. And these results both mathematically, statistically, and clinically significant results. On the next slide, we analyzed congenital heart defects together. We found that advanced maternal age increases the risk, while a very young maternal age can prevent congenital heart defects. And if you remember to our first study, in our population-based study, we've got an opposite result. And the explanation can be that at population-based study, we excluded the co-occurrence of chromosomal abnormalities. And chromosomal abnormalities highly influence the occurrence of congenital heart defects. While most of the studies which we could include to our meta-analysis, they haven't excluded it. So they found that in advanced maternal age, it can be more risky because chromosomal abnormalities are more frequent at advanced maternal age. And here is an example when we examine the individual non-chromosomal congenital abnormality. It's gastroschisis. We analyzed 22 articles, and we found that very young maternal age increases the risk. Advanced maternal age and very young maternal age both increase the risk of non-chromosomal congenital abnormalities, while advanced maternal age increases the risk of congenital heart defects. And we'd like to specify screening methods and use advanced ultrasound screening in certain age categories. And for the future studies, we would recommend study the biological background of them and use confounders, multivariate models to justify this knowledge. The strengths of our meta-analysis are the high number of cases and articles, the generalizable results, the low risk of bias, and the fact that it can be the first meta-analysis about non-chromosomal abnormalities regarding maternal age. But the limitations are sometimes the inconsistent categorization of outcomes, the different age categories, and the missing confounders. We are at the end of the article writing on this second project. And our goal also submit this project in September. Thank you for your attention, and please let me end my presentation with a quote from the Nobel Prize laureate Albert Szent-Györgyi. Research is to see what everybody else has seen and to think what nobody else has told. Thank you very much.
I would like to ask, I would have a question for your first study. Then when you define the comparator 10 years of wide range as a comparator, how did you define that? Which 10 years would you like to compare to? What kind of statistical method was it?
So our concept was we wouldn't like to use these arbitrary categories. So at first we defined the relative risk for each years. And then we choose the best 10 years after analyzing this relative risk question. And it was another for each non-chromosomal congenital abnormality, but they defined that for categories also and for all of them also. And you could see this, all of them, and it was from 23 to 32.